Well, let's solve the演習問題 for last class. And this is the question. First of all, this is a high-level code for a typical for loop with 9 iteration. And this is the corresponding MIPS assembly code. In the code, there are 3 columns. The first column contains the address. The second column contains the instruction itself, and the last one is the command. To execute this for loop, here is the corresponding MIPS code. And the question was, you need to find out the program counter address after executing the branch if equal instruction. Okay, that was the question. So how we can find out this? Before going to the answer, I would like to discuss a bit theory. So as you know, the branch instruction could be either conditional and unconditional. In our case, it's a conditional branch, and particularly it's a conditional if equal. And as you know, it's an I-type format, so you have only 16-bit immediate value. The problem is the MIPS address is 32-bit. So the question was, using this 16-bit, how you can address this 32-bit. And this part we will try to find out the procedure to get the 32-bit address. Here's an example that you can see that you have 16-bit immediate, and later on we will calculate. Let's have a look on this. So the instruction is here, branch if equal R5, R1, 3. That means if R5 and R1 is equal, need to jump. Well, find out the next program counter address. Well, we have our current program counter is 32-bit, and we have to find out the next current program counter after executing this instruction. So the first thing you have to do, you have to add 4. It's the hardcore, and you need to add 4 for the next instruction. Next thing is you need to add the immediate value, and on top of the adding immediate value, you need to add the sign extended value. If your immediate value is positive, the sign extension value will be all 0. If your immediate value is negative, the sign extension value will be 1. That means you can jump in upward and the lowerward. And this is the last 0 because you know our MIPS address is a word addressable. So in every case, the last bit will be 0. So once you add this, you will get the next program counter. That was the question. Well, let's move to the example. Here, if you see that when this line to be executed, the value of the program counter is supposed to be 8. So the current program counter is 8. And then we need to find out the next program counter, and that's 24. Well, so the first thing we need to add 4, as I said earlier, and then we need to add the immediate value, and here the immediate is 3. Well, and the next part we need to add the sign extension. As the immediate is positive, all the sign extension will be 0, and here is the leading 0. If you put any value followed by 2 0, that means you shifted the value with 2-bit. That means you multiplied by 4, and then the 3 will be 12. If you add this 8 with 4 and 12, you will get the next program counter address, and this is 24. And this is the answer. This way you can calculate the conditional branch next. This way you can calculate the next program counter address. Thank you for watching. See you next class.